So I'm very, sad that a great conference goes slowly to an end, but we have one highlight at the end, and I'm very happy to announce our last keynote, Annette Gigon, who is the keynote in the section Changing Traditions. Annette is my assistant here wrote me, is an architect. I would say she's one of the most famous Swiss architects and also internationally very well known. She's co-founder of Gigon Architects, where I just got the notice it was renamed. I don't know if it was really today. Now it's Gigon Partner Architekten. The office was established 1989. With over 3 decades of experience, she had led numerous award-winning projects, garnering international recognition for her innovative approach, showcasing her commitment to urban integration, sustainability, and also really building construction. From 2012 to 2023, so until last year, unfortunately, she held a full professorship at ETH Zurich for architecture and technology, and I had the pleasure to work with her, and I'm really sad that she left us. Beyond ETH, Archinect remains actively involved in architectural education and participates in international juries and conferences, furthering her engagement with cultural and public architecture. With her experience over so many years, she has seen many changing traditions maybe, and I have the feeling also her own building tradition has changed a little during the last years, but we will hear about that. Great that you are here with us today, Annette.
Thank you. I try to install myself here. Good afternoon. Hello, everybody. Thank you for the invitation. Thank you for the introduction, Silke. Well, it's an honor to be here today, and it's an honor to be the last speaker of the symposium, contributing to a happy ending, not a dramatic one, hopefully. Well, we do not find happy endings too often in great literature or in extraordinary films, rather in commercial forms of entertainment and in fairy tales, of course. Lectures, instead, usually also need a positive turn at the end. Otherwise, the speaker has failed. But anyway, we all need a happy ending of this big story we are all part of. And we are also in need of positive narratives, stories, to be motivated to work for, to be convinced, to believe in, to follow, and then to invest our time, our energy, our creativity, and our financial resources. They are all not totally unlimited. We wish for and we need a positive perspective for our future. Now I will try to present our story in different chapters, in different short stories, a kind of enumeration. And yes, will need also numbers to explain. Although I've never been a big fan of numbers in the past. Maybe like the majority of architects, I preferred books and films and storytelling. But interestingly, the word tell stands also for counting. And this is the case also in other languages. Raccontare, raconter, erzählen. So, numbers. Numbers like 417, 420, 425 ppm, parts per million, have occupied my mind for some time now. These rising numbers mark a turning point in our way of thinking and designing and constructing too, which I will try to lay out in this lecture. Over the course of our career, we have been able to translate some of our ideas into material. And this is on purpose, top-down. Here and there we selectively modified the Earth's crust, reshaped it, there and here, modeled it in different locations with varying concepts for multiple purposes. We architects, could create space for us humans, space for living, space for working, space for art, space for life, extra space. So I like the idea of architecture as an aeration of the Earth's surface. I like the notion of an interlocking of the heavy Earth crust with the light atmosphere, a kind of marriage. But in the past 5 years, we have started to look deeper also in this airy, elusive part. This is a little bit disturbing. Is it my hair or is it maybe my... If it's not disturbing you, I use this? Okay, good. Good. So, to describe my mindset, I have to go back to the 1970s. While in middle school, we discussed the Club of Rome's report of the limits of growth. We were alarmed. However, in the following decades, the predicted depletion of natural resources was constantly shifting into the future. It seemed that society, science, politics, industry kept finding solutions for the ecological problems just in time. Mostly there were technical solutions: sewage treatment plants, waste incineration plants, catalytic converters, the ban of CFCs and other pollutants, more efficient heating systems and exhaust gas treatment, LED lamps in the last decade, and, decade by decade, better thermal insulation of buildings. Since the 80s, since we studied at ETH, then it was about 5 centimeters we had to put in the construction. In summary, if we were willing and if we were informed and willing to comply with environmental requirements, we could go ahead, couldn't we? But now, in spite of all the efforts, other problems pile up in front of us. The quantity of plastic, biodiversity, the loss of biodiversity, and most worrisome, global warming due to the greenhouse gas emissions, due to CO2. So this substance, CO2, is the main problem, the main driver of global warming, a trace gas only. Today, precisely those 425 ppm of carbon dioxide, CO2. But matter always mattered in our work. We architects are familiar and often fascinated with the solid matter, with building materials, these substances which can withstand gravity, the force of the wind, the weather, and also whose sensuality we love. Sparkles, the sparkle of glass, the warmth of wood, the sedimentation layers of concrete, the coolness of bare steel, the colors of rusted iron. Even from the little valued insulation materials we gain some inspiration. This is a picture of an early exhibition we did in 1993 in Lucerne with a material rack as the main object. However, the building materials stand in relation to other substances, to fuels, to pollutants. In fact, today, we all lack an intuitive imagination of these counterparts of the solid materials. We lack an imagination of the liquids and gases that contain energy, of electricity, and energy without substance. And even more, do we lack an idea of their quantitative measures. Paradoxically, because we all got used to the availability of so much, and I say cheap energy. For most of us, The image of these substances and types of energy manifests itself primarily through their appliances, containers, screens, control equipment, pipes, ducts, lines, switches, intakes, exhausts. We place them in the basement, make them disappear, cover them up for different reasons, noise, smells, and of course, for reason of safety. Even less do we grasp the carbon footprint that our buildings leave in the atmosphere, and more generally also, this is true for our way of life. Around 37% of the worldwide CO2 emissions are presumably caused by buildings and by households, by the use for heating, cooling, hot water, appliances, etc. So my idea of architecture as a happy interlocking, a kind of marriage between the Earth's crust and the atmosphere has gone out of balance. Now, by means of a few selected projects, let me outline how we have dealt with materials over the course of time, with building materials, also with environmental materials, with construction. I start, as always, with the earliest project. The Kirchner Museum in Davos is at an altitude of 1,500 meters above sea level. Here, glazed superstructures, skylights, do not only serve as daylight traps, daylight equalizers, but also as buffers for the climate in the exhibition rooms below, here seen in section. And on the facade, the insulation panels of the bearing walls show through the etched glass panes. We wanted to reveal the construction of the wall and also feature the new climatic building requirements. For the first time, we used waste glass taken out of the recycling process. We used this old broken glass instead of the usual gravel covering on the roofs. Recycling of used glass in Switzerland was introduced in the late 1980s. The next project, the housing development Brunnenhof. It was the first project where we met the Swiss sustainability standard, building standard, Minergie Eco. The district heating is provided by the nearby waste incineration plant, and the exterior cladding of the opaque glass conceals a 20 centimeter thick layer of insulation now. Brick and also recycled concrete, we were told, were used for the load-bearing structure. Now, according to calculations, the building should only consume around 25 kilowatt hours per square meter a year for heating and warm water. This is the bar. This is the bar to the very left in comparison with other projects. This was the calculation. But then measurements, and we could read that in the newspaper, of the actual consumption read twice the amount of energy. But why? A miscalculation? Or too attractive balconies, maybe, so that adults and children are tempted to leave the French window open? We don't know. The Swiss Museum of Transport, with the entrance building and the road transport, they show an unconventional, playful approach to waste materials, reuse materials, Umweltmaterial. The facades of the entrance building wail shiny scrap metal in form of rims, propellers, ships, screws, and cogs. The metal pieces are mounted on a grating in the cavity between the cladding and the insulation. It is a not entirely uncritical tribute to the wheel, the nucleus of mechanized locomotion. Most of the metal pieces were first bound for the scrapyard. And also for the new road transport hall, the museum for cars, motorcycles, bikes, we considered using scrap metal in the form of old road signs. We covered the facade with used and new traffic signage. And we reversed the used signs that faced the neighborhood. But of course, the two museum buildings are exceptions. And this eye-catching approach can hardly be transferred to other buildings. Scalable solutions would be required. Nevertheless, the road transport hall was our first building to be equipped with a photovoltaic system on the roof. It's the one to the very left. To the very right, sorry. Then, in 2018, we began to prepare a semester for 2019 at ETH, collaborating with Arno Schlüter's chair of building system. The title was Stoffwechsel. Translate not so good, material metabolism. We wanted the students architectural projects to consider energy consumption and the embodied energy of building materials and the respective CO2 emissions. All of this is, of course, not our area of expertise. Was not, is not. And it's also not our subject matter. We are architects, we are not scientists. So one semester was not enough. We continued our research, search, self-enlightenment over several semesters, finally. We continued to try to gain an overview of the complex field of energy and greenhouse gases. The information we gathered went into readers like this for the diploma students. I flick through a few chapters. I start again with the limits of growth, this wake-up call 50 years ago. And although, as I said, the book was mainly about the finiteness of resources, a small graph showed already the increase of greenhouse gases. This forecast turned out to be correct. Charts from the BFU, Federal Department for Environment, with falling and rising curves. For instance, the annual measurement of CO2 concentration in the air on Mauna Loa, those 425 ppm this year. And the average greenhouse gas emissions for the Swiss population per capita, per person, 5.5 tons, which is not a lot because it's without imports. And with imports, it's around 11 to 14 tons per person, which is a lot. There's a chapter on energy. We looked into the data of the BFE, the Swiss Federal Department of Energy. The graph shows the development of the total consumption of energy in Switzerland from the 1900s. Today, then, I think it was in 2019, around 220 billion kilowatt hours. And of course, the Swiss population has risen since the Second World War. I think we are 2 times as many as then. But nevertheless, the mountain is quite impressive. Nevertheless, all of it is depicted in nice, soothing colors in blue and green. Nothing to be alarmed of. We highlighted the fossil fuels orange. Electricity is bright blue. And also in Switzerland, the fossil share is around 60%. We dared to look at the global consumption of energy sources, and this is around 80% is still fossil, and the curves are still rising. And also, so do the curves for the global CO2 emissions. In the reader, you find a chapter on material and energy flows in Switzerland. For instance, these data from the EMPA. All all shown in pie charts and bar charts. And concrete appears in blue, very prominent in this representation by weight in the lower left pie chart, but less so in the representation by greenhouse gases, the second left. These bar charts show more clearly the ratios of greenhouse gas emissions. The left bar is for the buildings and their use, middle is for mobility, and the right bar is for consumer goods and production. The most striking quantities we find for the emissions for fuels for heating. This is the gray, the dark gray in the left bar, left building bar. And then in the middle for fuels for mobility, the bright gray in the middle bar, and for food, the light green in the right bar for consumer goods. But of course, the building construction with the various materials also adds to a considerable quantity of greenhouse gases. You see in the left bar, again, the concrete in blue, the brick in orange, glass bright blue, steel yellow. They are not a quantity negligible. So we tried to take a closer look, an unbiased look at the materials we love so much, through the lens now of energy consumption and CO2 emissions. While the students in the design semester were given the task to transform existing office buildings into residential buildings and to extend them. Transformation, refurbishment, instead of new construction, this in order to save as much embodied energy and embodied CO2 as possible, quite a kind of reuse on site. We recommended extensions in wood for two reasons. First, weight saving for the existing load-bearing structure. Second, temporary storage of CO2, at least for the lifetime of the building. We recommended improvement of the insulation, changing the heating system if ever possible, the use of PV panels whenever appropriate. And this sounds all simple, but it was quite challenging for all of us. But it led to interesting solutions, like here, for example, the work of Micha Zand and Terry Dvoracek. The semester was about the careful, competent handling of existing buildings, also beautiful listed buildings, together with Silke, now and then. And it led to their retrofitting and transfer into the future. But anyway, here in Mendrisio, you are all acquainted with Reuso, which was introduced by Martin Bösch and by Muck Petzet and with Philipp Esch and many others. Now, as we broadened our horizons and explored the design potential of sustainable refurbishments, we wanted to know more about the quantities of energy and greenhouse gas. We needed numbers to understand the orders of magnitude. How much? Language has not enough nuances to differentiate. Good, better, best, bad, worse, worst. With the help of our assistants, in particular Arend Kölsch, we produced this brochure, Vademecum, that enabled us and our students to enter and to explore this complex world of data, units, and calculation methods. We based on different sources of life cycle assessment data from research, manufacturer information, various databases. In Switzerland, there is this public compilation of important life cycle assessment data in the construction sector, the KBOB tables. And this is how they look like. They are publicly accessible. On the different data, it's not difficult to calculate. You just need to know the rule of three. And you need to know which column of figures are relevant, of course, and also check the specific weight of the materials. But yes, the eco tool of ZPF structural engineers with Professor Jacqueline Pauli is more efficient if you have the skills to use it. We took, for example, 1 square meter reinforced concrete wall, 20 centimeters thick, with reinforcing steel as a benchmark, as a kind of currency to compare with other materials. What does this bad guy do? 1 square meter concrete wall causes about 60 kilograms CO2 equivalent of grey emissions for construction and disposal. And the steel reinforcing in it, with approximately 18 kilograms, contributes then to 1/3 of the greenhouse gases. And another example, we also compared with the emissions for heating. 1 single heating with natural gas in order to compensate for the heat loss in the uninsulated concrete wall in Zurich costs approximately 70 kilogram CO2 equivalent. This means the heating under these conditions releases more CO2 in 1 single year than the construction of the wall cost, which might last for half a century, it depends on us. And 1 single Bitcoin transaction generates around 400 kilograms of CO2 somewhere in the world, which is as much as 7 square meters of concrete wall, 20 centimeters thick, with reinforcing iron. According to some sources, it's even significantly more. With seminar evenings, we invited and involved experts and colleagues and discussed with students on Zoom. The invitation poster was a cheat sheet with interesting data. And we installed an ad hoc exhibition at ETH Library, Material Hub, with the CO2 data of building materials to get an overview. All the data, again, related to 1 square meter material and standard dimensions used on site. And you can discover how far we got during the last semesters at ETH. The link Infostand, Energie und CO2 should still work. Please help yourself generously. And what did we do in our practice in the meantime? We tried to win competitions. The visualizations just show a few competition projects, all of them with PV panels on the facade, dark, uncolored, efficient, instead of trendy coated ones with layers of bright colors and therefore impaired performance. We could not win any of them. But during this planning process for the multipurpose building for the Museum of Transport, we were able to convince the client that we should change the design of the facade again and continue with integrated PV panels. Together with the artist Urs Beat Roth, we proposed a pattern which produces a kind of trompe-l'œil between windows and PV panels. We mounted many PV panels towards the south, just a few towards the northwest, and none towards the narrow courtyard. The facades are now insulated here with 30 centimeters glass wool and clad with thin perforated metal sheets. A water-to-water heat pump in the basement supplies not only the building with heating and cooling, but already his neighbors and in the future also a large part of the site. But the difficult geology of the ground and the large span of the 30 by 30 meter for the ground floor exhibition space asked for an elaborate concrete construction. Despite the three office floors on top, the big exhibition hall had to be pillar-free. But we could also win competitions with different concepts. For example, the office building VAS, so social insurance center in Kriens, Luzern, based on the principle of thick walls and reduced openings, the building should be able to manage without heating, similar to the building 2226 of Baumschlager Eberle, and in collaboration with them. The load-bearing walls of the upper parts are brick and clad with insulating bricks, and the load-bearing structures of the lower parts of the 10-story buildings and the cantilevers are in concrete, and they are clad with insulation bricks too. The dimensions of the walls vary from 68 to 80 centimeters. A mock-up shows the future plasterwork of the facade, and the walls in the interior are rendered with clay plaster that will ensure good moisture levels. Ventilation is provided by CO2-controlled automatically opening window flaps. And the energy from lights, computers, and people will be sufficient to heat the office floors. For meeting rooms, cafe, etc., an additional heating is needed. The Crea Tower, an office high-rise of 40 meters in Zug, follows a different concept. Here the focus is on a light structure with little CO2 emissions combined with the use of PV panels. The floors consist of prefabricated RFS ribbon floor system elements developed with Philip and his block research group. And the PV panels form a prise soleil. The floor element is a very thin structure which gains its strength through geometry. The vaulted floor elements of 6.15 by 6.15 meters do not require reinforcement steel bars and have a thickness of only 8 centimeters. This is the competition detail. During the planning process, several demands led to adaptations of the ceilings. Now with 2 times 8 centimeter concrete and a hollow core, 16 centimeters in total is still a very thin structure for the given span. So, important to notice, not the requirements for the load-bearing structure led to the adaptations, but the requirements for sound transmission, fire resistance, vibration behavior, and the building logistics, etc. This is a mock-up and a test element. And the next project. We could also win a competition for a workshop building for the SBB, Swiss Federal Railways. The task for the workshop building was not only to construct robust ceilings for high floor loads, but also at the same time to find a construction with CO2 values not higher than 5 kilograms CO2 per square meter a year. This ambitious target could only be reached by reused material. Old railway tracks, which have to be replaced annually, form a mine of scrap metal to be reused in the buildings for construction. With the steel railway tracks, columns can be formed, and they are used as ceiling beams. And depending on which elements can be found in the second-hand material market, the building could look like this. Circular, a firm Barbara Buso co-founded, is supporting the team in research for reuse material. In analogy to the semesters at ETH, the Migros high-rise is an example of structural and energetic refurbishment of a listed building. The brick walls of the listed tower block were crumbling and had to be renovated. And And the building had also to be retrofitted for earthquake resistance. Oh, sorry, thank you. I should look on the pictures too, not only into the text. Thank you. This is the building as we found it. And this is the retrofitting reinforcement. And we were able to convince the client to combine both with an energy-efficient refurbishment, with 20 centimeters of insulation clad with a new clinker brick wall, which would withstand the weather better than the former brick wall. This is a view to the renovated building, of the renovated building. And this example, the next project, shows the challenges that can be connected with energetic refurbishment. You see a well-maintained, solid residential building from the 30s with rendered brick walls and wooden ceilings. What are the options for a client? The building law would permit a high-rise building or a replacement of the building in standard construction. Instead, we suggested to study how the building could be made more energy efficient and also have an extension on top, the left solution. But we learned that upgrading the facade and switching to a heat pump would have to be accompanied with a general renovation in accordance to today's stricter standards and regulations in other fields. For instance, for the existing wooden beam ceilings, the standard today asks for better sound insulation, improved fire protection measures, earthquake resistance, upgrading, etc. This means a costly core refurbishment, of course, with accompanying cancellations of rents. Can we question these regulations? Scrutinize them? Not in reality. The architects have to fulfill them. So today, many owners who want to improve the CO2 footprint of their buildings, which are still okay, are faced with difficult decisions, refurbishment or new construction. And please note, approximately half of the buildings in Switzerland are not insulated yet and or are still heated with fossil fuels. So, this last example is much simpler. It shows a solution for a decisive energy and greenhouse gas upgrade regarding the operational values without structural intervention. This is because the basic requirements were already met. The two houses from the late 90s are already insulated with 12 centimeters of rock wool, quite modest, and have underfloor heating. But firstly, the residents lowered the room temperatures to 19, 20 degrees, 1920, and placed thermometers in the rooms in order to control the temperature. This already resulted in a reduction in heating energy of approximately 25%. And they put on jumpers now and then. Then the natural gas heating was replaced with a brine water heat pump. As a result, the energy consumption was once more reduced by a factor of 5, even bigger than 5. And with the heat pump operating with Swiss electricity mix, the CO2 emissions are now around 10 times lower than before. Operating with solar power, it would be more than 20, even 30 times lower in comparison to the former initial CO2 production. A PV system on the roof is in the planning phase. Well, in order to pay off the already spent embodied energy and emissions of the former construction process over many years, preferably decades to come. We have to extend the life cycle of buildings to 60 years at least, preferably longer. And we have to look for the most effective and most innovative levers to cut down the operational CO2 emissions when dealing with existing buildings. So we learned that the observation perimeter, the scope, must be extended in order to be able to assess, to judge the overall footprint of buildings. Besides the construction and the insulation, besides intelligent building systems in combination with photovoltaic, behavior and the use of the residents is also decisive. And yes, also the length of the life cycle of a building is key. The latter in particular to today being called in question by increasingly stricter norms and higher standards. Let's take another last look at the figures and data. You see what it is all about. The graphic shows the share of buildings in CO2 emissions worldwide. Construction is around 10%. The use of building, heating, electricity, etc., still around 27%. 37 in total. And the graphic from Arndt Kölsch shows the share of buildings in greenhouse gas emissions in Switzerland 2022, according to the data of the Federal Office for Environment. The construction is in the same range, approximately 10%, and the use here is also still dominant and around 30%. Altogether around 40%. But this is good news for architects and users too. The charts, again from the BFU, Federal Office for Environment, show how greenhouse gas emissions have developed in the various sectors since 1990 in Switzerland. The building-rated sectors, the households in green and also the services in yellow, are doing best. And this despite the fact that the population and the building stock has increased since then. However, the two curves do not hide the fact that things are going too slowly and that it will take a lot of effort to make further, faster progress. With Arndt Kölsch, we are in progress of compiling a handbook that will provide architects and students and clients and lay people with an overview. It organizes the many figures and data. It also shows how to calculate with them, simple, and even where to find more data if you want to go further. It's a kind of bridge builder between science and practice, a book as we would have wished for when we started to deal with the complex matter. It will be published in summer. And the title, Ein Einstieg, translates, means a start, an entry, a first step, an introduction into a new alphabet to gain a carbon literacy. A carbon literacy in order to read this big story we're all part of, but also to be able to act and also to be able to play a decisive role in it. So as promised, I do not end with a simple happy ending, but with an open one. But this symposium is most probably a happy beginning. Thank you for listening.